So from this section, I'm going to talk about the technical details about how to construct the control charts, especially for the variable measurement. And we are going to focus on the variable measurement for today. You are really looking at 3 different control charts under the variable measurements. By the way, by saying variable measurements, we're talking about your quality dimension is being measured using continuous scale, okay? Like time, weight, and speed and things like that, not in terms of 1 and 0, not in terms of count. So we're gonna start with X bar and R charts because it's going to give us a full flavor of what it is look like. And then we're gonna move on to X bar and S charts because it's an extension. It's just using more number of samples. Therefore, it is easier to make a connection between the X bar and R. And then we're going to finally move to the X bar and moving range charts, which is a case of sample size number 1. It may feel a little different, but what they are trying to achieve eventually are the same. So really, when we're talking about X bar and R chart, we're really talking about a sibling, right? We're talking about range charts and sample average charts. So this is R charts, this is X bar charts. This tells you about the process variability. This one tells you about the process average. Okay, that is the reason why we need to rely on 2 different charts to learn about the process. Again, I think I mentioned this in the earlier of the class. Not only the average of your process is important, the variations of your process is also important. Okay, to construct, you need to collect. You need to initially collect large number of samples. Okay, large number of samples. By saying number of samples, I'm not saying the sample size. Okay, you need about 25 to 30 different samples, with each sample has a sample size of 3 to 10. Okay, of course, it needs to be consistent from sample to sample. In other words, you need to collect, for example, 25 different samples, with each sample has 3 observations. It means in this case you have total 75 observations you can utilize. That is what I'm talking here by saying the difference between the number of samples and the sample size. Okay, usually number of sample is going to be using K to indicate, and sample size will be using lower letter K to indicate. So for each sample, calculate the sample mean and the range. Okay, that is going to be the initial data to construct the X bar and R charts. And then obtain and draw the center line and the trial control limits for each charts. Of course, to construct the range charts or R charts, you need to obtain all the ranges for your 25 samples. The ranges, again, meaning the difference between the maximum and the minimum within the 3 observations you have drawn for that sample. Okay, and then for overall mean, it is the average of all 25 different samples. Okay, so if you're kind of fuzzy about these, don't worry, I'm going to demonstrate them later eventually. Okay, so here is a brief overview of the formulas you will use to construct the X bar and R charts. So again, R bar is the average of all the ranges. So let's say you have 25 different samples, and for each sample you can obtain their range. Range is difference between maximum and minimum, and you do this calculation for 25 times, you get the average. That becomes your average range. Okay, that is one way to measure the process variability. With this obtained, to construct a control limit, you multiply D3 and D4. These are some constant you can use to construct control limits. For these constants, you need to look up the table. You need to look up the table either attached in the textbook Appendix B or from this link, or you can just search the Google control charts and D3, D4, and I think Google will give you a lot of relevant results for you can look up. Okay, excuse me, with this R bar constructed, you are going to take it to construct the lower control limit and upper control limit for the X charts. Okay, for this X bar is the average of all averages. Okay, so we have 25 samples, therefore you are going to be able to do first sample average, second sample average, all the way until 25 different samples, their average, and you divide them with 25, you obtain sample average of all sample averages. Okay, so that is this line here. And again, A2 is a constant you'll be utilizing to construct the upper control limit. So conceptually, this is important. Conceptually, this upper control limit is equivalent of X bar plus 3 standard deviation with this. Okay. However, like I said, because of sample size is too small, estimation of the standard deviation is going to be not accurate. Therefore, over time, people traditionally used these techniques to multiply the average range with a factor, which is a constant, which you can also look up from the table here, right, to approximate the 3 standard deviation range. Okay, so by the time, I think I'm expecting you to rely on the formula to construct your own limit. But let's continue the discussion. So what does R chart reflect and how to use it? So when you actually use it, right, you would like to look at the range chart first, meaning R chart first. Range is used to calculate the standard error because the cost of the sample size in these cases are usually very small. Again, if you're a laptop manufacturer, you cannot draw a sample of 10 or 20 each time, right? Even 2 or 3 is too much. Thus, obtained sample standard deviation is not a good estimator. Again, I discussed about that. Traditionally, standard deviation believed to be a function of the range. Okay, that is the basis for those D2, D3 things. Okay, there are some sophisticated derivation process, but I'd like to skip that. All you need to know is we need D3, D4 to construct the limits for the range charts. R chart reflects the process variability, which should be brought into control first. So we'd like to control the process variability first. If the variability is not within control, that means your X bar chart is kind of useless. Okay, because X bar chart is X bar plus minus your A3 R bar. If this R bar is not within control, and there's no meaning of discuss about this range. Okay, so the typical way of utilizing the X bar and R chart, even we're saying it's X bar and R chart, we are going to take a look at the R chart first, and then determine what is going on with this system, and then we move on to take a look at the X bar chart. So in other words, we have 2 aspects that we need to control. Okay, we like to see eventually this matters. However, without knowing this is under control, looking at this itself is meaningless. We need to put this thing under control first, and then we can take a look at whether this thing is under control or not. Okay, so with that, I'm going to stop here, and I'm going to record the solutions of all these exercises in the next video.